All right. All right, let's get started. So today, we're going to talk about high availability. My name is Mel Boulos. With me is Michael. And we're going to walk you through where we are today from a high availability standpoint. You've already seen the passionate leadership that we have in the keynotes. We have the same passion, and we're going to talk about that, how beautiful Couchbase is and how we handle availability. And we're going to take that one step further and talk about some of the cool features in 5.0. So we just want to thank everyone. We know that from a tech standpoint, everyone's busy, and we certainly appreciate you coming out and listening to Couchbase. And hopefully after today, you'll have a good idea of where Couchbase sits in the marketplace, when to go back to your organization and say, hey, you know, I think Couchbase could be a good fit for a variety of different use cases. Before I begin, I just want to kind of get a quick gauge of, with a show of hands, who's running Couchbase today? So we got about half the, for those that aren't running Couchbase, are you running any NoSQL? Couple NoSQL, which is great. So I mean, by all means, hopefully if you're just running NoSQL, maybe it's, you know, Cassandra or Voldemort or, you know, Mongo. Some of this will translate, or at least you can kind of figure out, okay, they handle availability this way, and Couchbase, you know, solve some solutions, you know, the way they do. So we're going to start off with high availability. And whenever we think about availability, we do it through three different kind of solutions. So we're all coming from the relational world, and there's primary three different areas that we're looking to solve. That's availability, performance, and scale. And today we're talking primarily in availability. So when we think, you know, when do I want to use Couchbase? It could be that, hey, I can never be down. I got a critical application. You know, you've seen some of the logos, you know, Apple, Marriott. You know, those are key customers that have the 5.9 approach, and they can never have a poor user experience, because we know 80% of your customers are not going to come back if they have an undesirable experience with your product. So when we think single point of failure, we solve that through a couple of different ways, and we do that through replication. And we replicate within the cluster, and we replicate between data centers. So within the cluster, we do it from memory to memory. So here you're just looking at a 3-node cluster, and we differentiate our active and replica copies. So when we define a bucket in Couchbase, it's synonymous to a database in the relational world, and each bucket can have their own replication strategy. Maybe I define one replica for a user bucket and another replica for my catalog bucket, and in each bucket is what allows me to accept failure. So as data or hardware fails, the replicas will get promoted, and we'll talk about that here in a little while. Rack Zone Awareness came out in 2.5. It's an enterprise class feature, and what that means is that when you define and tell Couchbase, hey, I'm going to deploy Rack Zone Aware, and when I tell Couchbase I have a server, and I'm going to give it and place it on Rack 1, and my second server comes into the cluster, and it's going to reside on Rack 2, Couchbase will know not to put the active and the replica copy in the same rack. So that thereby eliminates any single point of failures. So my data is always available, and as we go through, and we'll talk about the auto failover process, that'll get initiated, replicas are promoted, and I'm able to always serve data to my users. And there's a couple of different key things that we'll talk through, and the XDCR is another key feature that hopefully you'll become very comfortable and aware of. So here we're just looking at the 3-node cluster, 3 racks, 9 nodes in my cluster. Rack 2 goes down, and I know that my replica for my active copies in Rack 2 reside somewhere else between Rack 1 and Rack 3. So I don't have a situation where my active and my replica copies are on the same rack, making the data unavailable. And as we go through, just by all means, please, you know, raise your hand if you got a question. We got the mic in the back. He'll come to you, and you know, so everyone can hear the question. But if you have any questions as we're going through, feel free to just chime in, and it kind of gives us an idea. And if you have a question, more than likely the guy beside you has the same question. So let's just walk through our failover type scenario. Here we've got a 5-node cluster, and clusters are defined at the data center level. So when I think about a Couchbase cluster, it's a data center in Boston, it's a data center in New York. And as I go and deploy, these nodes will communicate to one another through a variety of different gossips, heartbeating, and they exchange different states. So here we're looking at just the third node. It's down, and the other nodes are saying, hey, I can't get any response. The state that node 3 is sending me is that it's unavailable or down. When this time period through auto failover is defined at the cluster level, that time period will come and go, and replicas will get promoted. And when we talk about replicas getting promoted, so if we just kind of focus on shard 3, on server 3, node 3 is down, my replicas are promoted. So in this case, shard 3, which lives on node 2, the replica is promoted to an active state. So data is not physically moved. The data is already there on the respective 4 nodes, but the replica is promoted and my data is now available. Now that window of failure can be controlled, and we're going to talk about that here in a little while, and we made some very, very, very cool improvements to how quickly that failover occurs. So just to give you an idea of, that's how we handle failure, that's how Couchbase understands how nodes are down through gossiping and heartbeating and exchanging of states. Any questions? We good? Go ahead.
So when I write a record to the server 3, and it takes some time to replicate the data to another server. So before you promote to the master, do you maintain or make sure that ECP pick up the latest changes before you promote it, or you just promote it in advance?
Yeah, so that's a good question. So when a failure does occur, it's completely transparent to the client. So the topology of the cluster can change, whether it be a node going down or a node being added. When a write is written to Couchbase, it's written to, based on the CRC32 hash, to whatever respective node. And if that node is down, it'll continue to retry until either failover is initiated or the node comes back online. And then once it hits its primary node, is replicated memory to memory. So in a healthy state, replication is memory to memory, and it's within sub-milliseconds. So the application, even if it is a situation where I want to read my writes, I write it and then immediately read it, Couchbase will always serve that data. There'll never be a situation where, hey, I just wrote it, I can't find it. Does that make sense? Does that answer your question? Go ahead.
After one shared promote to active, so they will load replica for that shit at that moment.
Yeah, that's a good question. So in the event that a failure does occur, so here we've got the 5-node cluster. Replicas is promoted from a replica state to an active. If you think about how my replicas are distributed, because I just promoted a replica to an active state, I have data that doesn't have its replica. So in order to initiate a copy or create a copy of the replica that's been recently promoted from replica to active, I got to run rebalance. Does that make sense? So I accept one failure, node goes down, failure is initiated, replicas are promoted, but because if we just focus on shard 3, its replica is now in an active state, I don't have a replica for shard 3. Rebalance would create that replica. It'll go through and distribute that through. Go ahead.
Just one comment to the previous question. By default, we'll only write basically to the primary and we'll send you the successful response back. But you have an option available inside the SDK which gives you more control over when the client signals success to you, right? So you can say, only tell me it persisted the data or the write operation was successful if the data got replicated and or persisted to a specific number of replicas. So you would control the consistency behavior at failover during the write operations. Of course, the trade-off there is consistency for throughput, basically, right? Because it obviously takes longer to replicate and or persist to disk, right? So that's the trade-off you can make on a per operation basis, which then affects how the data looks like once the actual failure happens, right?
Yeah, that's a good point. So the durability is controlled at the operation level. The default is my managed cache, and I think there's a slide here that actually illustrates our managed cache. the managed cache gives acknowledgement back to the client. That's our default. If you say, oh, you know what, I want to receive acknowledgement from the primary node and the replica node, I want to wait for that replica node to actually come back and say, I got the data too. So now I've got that second layer down that says primary and replica both acknowledge that they have it. If I want to take it one step further, I can say I'd like to wait until the data persists to disk. So now I'm absolutely convinced and sure that I'm never going to lose data because now I'm waiting for Couchbase to persist it and then give it an ACK back. So it's 3 different layers. I think all of us pretty much know that anytime I go to disk is when or any database for that matter, is when I'm taking some sort of trade-off in performance. And then later, Michael's going to talk about the multi-data center failure type scenarios to where one data center is down, how our clients will communicate to another data center. So again, that's another level of availability to ensure the data is always made available to the clients. Okay, it's a good question. So yeah, this is just walking us through. The shards are promoted, and the cluster map, which we don't talk about too much in this content, but the cluster map is what tells our smart clients, our SDKs, where data resides. So based on my CRC32 hash, my user record is going to be sharded to shard 8 on node 1. And that's where I'm always going to be directed to get my data. So if you are familiar with the CAP theorem, so there's quorum-based architecture, which is Dynamo-inspired, Cassandra, Basho, or Riak. And then there's Couchbase is more of the C and the P, where in the Dynamo architecture, which is a quorum-based architecture, was the A and the P. So in quorum-based architecture, 3 copies are always distributed. Whenever I ask for a piece of data, 2 of the 3 nodes will at least respond, and then they have to agree on the data or the version of the data to send back to the client. Where in Couchbase, you're never going to get in a situation where Couchbase is going to respond with 2 different versions, because we're a strong consistency model, and you'll always be routed to the appropriate shard or partition or vbucket on the respective nodes. All right. So in 3.5, we actually introduced something pretty cool, and we call it the Delta node recovery. And this is, again, it's an enterprise feature. And what this tells Couchbase is, so if I bring it back pre-3.5, when a failure occurs, a node comes back into the cluster. Maybe that node went down for maintenance. Maybe it went down because there was a small hiccup on the network. But nonetheless, I'm trying to add that node back into the cluster. Couchbase will say, hey, I see that this node was part of this cluster. It has a data directory, but I don't know how long that node was down for. So what I'm going to do is I'm just going to send it the entire data set. Maybe the node was only down for 5 minutes, but Couchbase will send a full data set, and that's the full node recovery. In 3.5, we have Delta node recovery that says, you know what, I'm going to make it a choice. Do I want to do Delta or a full? In this case, I'm going to do a Delta node recovery, and I'm only going to send the data that you're missing within that 10-minute window. So what that does is it increases my recovery time, and it decreases the amount of data that I'm sending across my network. So you make a decision. Do I want full node recovery, Delta node recovery? Delta node recovery is obviously the way to go. It's a lot faster. It's a lot cleaner. Couchbase knows, based on its internal checkpoints, what data it's missing, and only send 10,000 operations or mutations opposed to 2 billion to send across the network. Go ahead.
Is it just a judgment call to do a Delta recovery, or do you have any statistics you can look at?
So we internally have a lot of benchmarking from so as you go through and add nodes into the cluster, right? Some customers are like, oh, geez, it's taken 5 hours to add my node into the cluster because of rebalance, which is a background process. Operations are still served up, but customers will say, oh, it's running 5 hours. When our approach is, well, that's okay. It just runs in the background. It's throttled. It's not impacting your operations. And you're always up. Where the Delta node recovery, that will take 5 hours and bring it down to 10 minutes. So, make sense? Go ahead.
During the Delta recovery, if my application client read the data on the replica, is that possible that I get partial data or the latest
So if I understand right, so during a delta recovery, and I ask, okay, gotcha. So as I go through, let's just say that node is being introduced into the cluster and I'm running rebalance. That node actually doesn't serve up any data until it's fully up to speed on its full data set. So although it's part of the cluster, it's receiving data, but its replicas are still somewhere and been promoted to active, or you're doing a replica read. That data will be served up from one of the other nodes, where until once the node is fully brought into the cluster map is updated, then it'll start to actually serve up transactions. Does that answer your question? Yes.
My question is, if during the recovery time, if I call get replica, will I get the replica data from the recovery node, which is the node which is in the recovery state, or I won't get it?
So if you do replica read, it'll go to, it won't go to the recovery node until it's fully brought into the cluster. Yep.
Is the delta recovery have to go through the warm-up procedure?
So the warm-up procedure, when you're bringing in a node into the cluster, there is, we still maintain an access log. We still maintain the most recent IDs that were in cache. So that's the first place we're going to go to populate our cache. So yes, still go through that process. Yep. Any other questions? All right, got one in the back.
Click it to auto deploy, or does it just come right back up?
So if the node fails, there's a time window, so that failure window. So in this case, let's say prior to 5.0, it's 30 seconds. The heartbeating occur. The nodes will say, hey, I'm not getting a response from node 3. That 30 seconds will come and go. Auto failover kicks in, promotes the replicas. Make sense? So which is another good point. So in some use cases, our customers think, hey, 30 seconds might be too long for us. We're not ready for to wait 30 seconds. So they'll disable auto failover, because you can either it's enabled or disabled. And if it's disabled, they'll write their own monitoring using CB stats and a REST endpoint that says, hey, I'm going to keep checking the statuses of certain nodes, and if they come back down or unavailable within 8 seconds, I'm going to initiate an auto failover myself, because I can script out auto failover, I can script out rebalance, I can script out a node, adding a node. So all that is I can automate that. Our stance is if you do that, you got to make sure that you're doing it and you're not having a false positive failover to initiate all this adding of nodes and rebalancing and moving of the data. Make sense? Okay. All right, so I think that covers the full recovery, Delta node recovery, and where we stand with that. Again, it's enterprise only. Let's talk through some of the DR. Now, DR is, from a relational world, is, oh my goodness. DR from a relational world is vastly different how we are today from a NoSQL. So when we think about cross-data center replication, we do it either unidirectionally or bidirectionally. And we could do that at the bucket level. So earlier I said I define a bucket, I specify the replicas. Well, maybe a bucket has session data, or maybe it has data that times out or ages out, and I don't want to include that in replication to Boston or from Europe. Or in Europe, there's some restrictions that says if the data starts in Europe, I don't ever want to replicate it anywhere else. XDCR has that ability to do bidirectionally uni. It also puts data closer to your users, so you can truly have a global type deployment, thereby increasing performance and enhancing your user experience. Let me just kind of zip through. That's, kind of breaks down. Again, all these slides are available to you. Same with the live feeds and all the video. But this just breaks down. I can specify a source, a destination, and how do I define it out. And it takes 10 minutes. If you've gone through any of our Couchbase days, we got a cross-data center replication lab. It literally takes a 5-minute step or lab to get XDCR up and running. So here's just a kind of a visual. you'll see a replication queue, which is within my cluster, a XDCR queue, which is within to another data center, and my disk write queue, and that's where it persists. And all that is simultaneous. So when my client comes back, earlier we said the acknowledgement is from the managed cache. That then will put the data or the document in 3 of those queues and replicated memory to memory within the cluster, memory to memory to another data center. Conflict resolution, this is pretty important. So earlier, our earlier versions, we just monitored the revision ID. So we store the metadata for every document in cache, and we would just increment the revision ID and figure out, hey, this revision ID is a lot higher than the other document because I'm doing multi-data center replication, bidirectional flow, and then I'd figure out what the conflict is. Where in 5.0 or 4.6 is when we came out with timestamp, which is last write wins. I've got a hybrid logical clock, which I synchronize all my nodes on time, and then I store the CAS, the time in my CAS, which is a compare and set or check and save. It's in metadata. That's what we use to figure out where conflicts are and who's the survivor. Just to run through, I think this is more just to give you an idea that we do have the ability to do backup. We've made some great changes. We've got diff backup. We've got incremental backup. Our approach is we're a distributed architecture. If you always want to be up, we will recommend using XDCR, but you also, if you wanted to write to, some file system or copy to tape, you also have that ability with our backup procedures. So 5.0, pretty cool thing, and this I want to really highlight as far as the failure, because this applies directly to availability. Let me just hold on. Because I know we got he's got a little sign that says I need to hurry up. But so from a failover standpoint, previously it was 30 seconds, and so earlier I walked through the scenario of, hey, I want to minimize that 30 seconds because I always want my data available. In 5.0, we built in some monitoring. We've given you the ability to minimize the 30 seconds to 5. So now failover through our monitoring tools, and I'll show you what they really are, but there is not a risk of that false failover of nodes and moving a data or even getting a situation where I thought I should have failed over, but I didn't really need to. So here I just walk you through. It's a 3-node cluster. You'll see my cluster manager lives on every node. And then I've got a data service monitor, and my node monitor is what is talking to all the other nodes and figuring out, hey, are you up? What's your status? I'm healthy, I'm not healthy. And then it'll send and analyze that through my node status analyzer. And then that's what's really going to tell Couchbase, this node absolutely is down. When I do a failover, I'm 100% sure that it's an accurate failover and there isn't a false report of a failure. So with that, I think here's just some of the breakdown, right, for later release on, how do I detect if there's failure? When do I want to know that the failure? How does Couchbase handle it if a service goes down or if there's a network issue? And then failover is initiated. So Michael, I think I'm going to run it over to you. And
Thanks,
how are we looking on time?
We started a little late, so we probably got like another 15 to 20 minutes before.
Okay. All right. So I think we're in good shape then.
Yeah.
Is there any questions? I know that I kind of ran through super fast. Is there any questions that we want to hit up on?
Quick question on the 5 seconds window. Of course, there is a false alarm where a network glitch can cause one node to be out and then coming back as well. So how does that get handled?
Yeah, so depending on that time. So let's just say I set it to 5 seconds and Couchbase says, yeah, 5 seconds is come and gone. I'm going to initiate failover. So that node is now failed out of the cluster or failed over, and what used to be a 5-node cluster is 4, right? My replicas are promoted and my data is now available. When I go to bring in that node that failed, maybe it was a network glitch or maybe somebody tripped on the power cord and the node went down. When I bring that node back into the cluster, that's when I would do the delta node recovery and say, hey, I'm bringing this node back in. It was previously in the cluster. It has all the data, or 99% of the data, and I'm just going to add it in. It's going to take a very short time period to add it back in because it's just checking for deltas. Make sense? Was there any other? I think there was one more question here. Yeah, sure. You wanna fire off some? We got a little time. Okay. All right. Is there any other questions before we get into the demo and the next piece of multi-data center failover? All right. Very good. Oh. Okay.
Did work in the other room. Thanks. Right, so Mel covered the basics for intercluster application and touched a little bit on XDCR. The other thing I'd like to talk to you about today, spending 10 minutes or so on, is high availability from an SDK point of view. And in general, if you're interacting with our Couchbase SDKs, basically what you're interacting with is a single cluster instance, right? So you are instantiating a cluster object, you're opening buckets, and then you're performing your operations on them, right? Key value, query, whatever. So despite having XDCR maybe synchronizing data in the background, either uni or bidirectionally between clusters, from an SDK perspective, you're still only talking to one cluster. Now, we got customer feedback and user feedback that maybe there is a way to basically build another level of abstraction from an SDK perspective to talk to multiple clusters at the same time. Now, as you can imagine, it changes the semantics quite a bit because, as Mel pointed out, inside a cluster, we are strongly consistent, right? But as soon as we talk to multiple clusters at the same time, the semantics are totally different, right? We are not strongly consistent anymore. Think of the simplest example that you can visualize is that imagine you are trying to, or you're modifying the same document in both clusters, right? Despite being replicated from one side to the other, there must be some kind of way to detect what is the right version. And we improved this story heavily with the last write wins clock-based conflict resolution. But still, there are situations where that's probably not enough, right? Depending on the application semantics, it can still lead to data loss, right? It's not that, because if one document is overwritten and the other one is dropped on the floor, the document dropped on the floor is lost, right? Unless you take additional measures from a client perspective. So it's a tricky topic, and it's, I'm trying to give you the high-level rundown. One quick mentioning, what I'm telling you, or what I'm showing you in a demo as well, is that what we call the multi-cluster or Java SDK. And as you can see, we're not very creative with giving it names, right? We're engineers, so we still need to wait for marketing to get the hands on giving it a nice name. But it's currently not open source. We're thinking about doing that eventually. But we are, because it's such a complex piece of technology and it really requires you to apply it to your domain, we are currently working with customers in a pre-release state and trying to get it done, right? So if you are interested in that and you want to play with that in your environment, talk to me later and we can work through the process. All right, so looking at this from, again, single cluster, single SDK perspective. This is what you'll do 99% of the time when you are working with your application, right? Your application instantiates the SDK and the SDK underneath by using the cluster map, by using all the replication mechanisms, knows where the partitions are, knows where the different services live, so we have multidimensional scalability, so you can have query on one server, key value on the other, and the SDK will make that all transparent to you, which is kind of nice because you can develop your applications on your notebook and then deploy the same application to a 50-node cluster, and you don't have to change the way you're interacting with the application, which is not the case sometimes with other solutions. All right. So how does the picture change if we span it up into multiple clusters? So instead of talking to the SDK directly, you're talking to this multi-clusterware SDK, which in the background manages the SDK connections to the cluster instances transparently, right? So if you're connecting to or connecting with the multi-clusterware SDK, as you'll see later in the demo, you give it a topology, and the topology represents the different clusters, and you can assign priorities to them and other certain properties, since most of the time, one of the clusters is probably more important, especially in disaster recovery scenarios. You want to talk to one cluster, and then if failure happens, you want to switch to the other, for example, right? So you need to tell the SDK to prioritize one cluster more over the other. So during regular operations traffic distribution, what will happen is that you're running your bucket level operations or cluster level operations, a nickel query, key value get, for example, against the cluster with the highest priority, right? So everything is fine, you're serving your application, but then suddenly there is a problem, right? So there is failure happening, and the term failure itself is a pretty complicated topic, right? Because failure can mean different things for different users or for different application workloads. Imagine sometimes maybe you're thinking a failure is like a node goes down. But also, if you are defining SLAs for your application, failure could also mean that your GET responses are returning over 500 milliseconds, right? So no node has failed, everything is operating, it's just that a subset of the responses are slower. And then if that's not in your SLA, well, then you could argue that's still not what I'm expecting, right? So you maybe in this situation still want to go to the other cluster, right? And this is why we've, in the multi-clusterware SDK, introduced the notion of failure detectors, which are highly configurable and composable, right? So you could say, signal failure if 50 requests in a 2-minute time window that are key value operations fail, or 2 nodes go down, right? So you can compose them and build a failure strategy that really shows and mirrors what you need from a business requirement point of view, right? And implementing that logic is really the key piece in this software that takes the complexity away from your side. You can configure it and will handle the hard part in the background. Now, if you're talking to multiple clusters, you may be thinking, how does the data go from one cluster to the other? And the answer is, of course, so we have XDCR, right? There is a timestamp-based conflict resolution, which we highly recommend you to use. But once you're using bidirectional XDCR, even with the time-based conflict resolution, keep in mind that, again, you need to be very careful to think about which documents you're especially concurrently accessing from both sides. And if you only talk to one cluster at all time, and then you go from one cluster to the other, it makes it easier to reason about the application. So as soon as you talk to both at the same time, it's a little harder. And the key point here is you might think, okay, well, I'm just talking to one cluster, that's fine. But imagine you have 50 application servers talking with one cluster. And then 10 of them decide, hey, it's time to fail over. And then 10 fail over and 40 stay with the old cluster. So suddenly you have 40 application servers talking to one cluster and 10 to the other, right? And then maybe you're running into a situation which you haven't planned before, which can lead to data loss, right? Because they are updating documents at the same time, leading to conflicts and dropping documents on the floor. And those are also situations that you can configure with our coordinator approach. So by default, we'll ship with what we call an isolated coordinator, which doesn't communicate. But what we have in the pipeline are basically coordinators which which signal between the application servers with something like etcd or console, so that you can configure a grace period if a majority of the application servers detects that one cluster is down. We are basically introducing some kind of a write barrier where all application servers stop the traffic, then they switch over, and then they start the traffic again. There still needs to be some considerations in the background with replication delay and so forth, but it really decreases the chance of accidental data loss in those cases. And so as you can see, right, once we go from one cluster to many clusters, there are many more things that you need to consider in a high availability scenario. So, and we also support other topologies in the background. So you can configure XDCR ring topologies and assign priorities from the multi-cluster client, and then we'll walk them in the list, for example. So how does it look like under the covers? So your client application talks with a bucket proxy, which then in turn has this coordinator piece that coordinates with the other application servers. And it maintains a topology, and the topology represents the current cluster topology in the background. And then each bucket is basically wrapped with this failure detector that you configure, and it will signal failure to the coordinator, and then the coordinator will decide when to fail over, right? So that's how it looks from a very high level underneath. And to give you just a very quick impression of how that looks like, with our couple minutes left, let me give you a quick demo. So to set the stage, I got 2 clusters. I got 2 clusters, and currently they're not set up with XDCR. We could do that, but let's not do that now. The important part is, so one cluster has 2 nodes. They're running the key value service, and one is running the query node. And then we have another cluster which only has 1 server, right? So as with XDCR, you don't need to have a complete exact configuration, because sometimes in a disaster recovery scenario, you maybe want to have your recovery cluster to be significantly smaller, since running them both side by side in a hot standby mode maybe is too expensive. So what we'll do is, oops, there we go. All right, so let's see. Actually, let's start with the other example. All right, so let's quickly look through our simple Java program, and we start by configuring the multi-cluster client. So the first thing we'll do is we'll create our cluster specs, and here we are, it's a very simple configuration. In the basic case, we are telling the client, okay, there are 2 clusters at those IP addresses, right? And we also define, then we initialize our coordinator with this topology information, and then we can also configure a grace period. And the grace period is the time that once failure is detected, the client will wait until the failover happens, because sometimes you want to give it some time for the situation to stabilize. And there are other options as well available. And the next thing we'll do is we'll set up our failure detector. And the failure detector here, what we basically tell it is, if there are equal or more to 5 operations in our 60-second failure interval, so it's basically a sliding window, and if failures are happening in this sliding window, then signal the failure to the coordinator, which then performs the failover. Okay, that's a very simple setup. You can configure the types of exceptions that are, for example, considered. You can decide if only specific operations are part of the failure configuration. You can have different configurations for different services, because maybe you want to have different setups for a nickel query than for a key value operation, because it has higher latency naturally. Okay, so, and what we'll do then is we'll initiate our cluster client, we give it a coordinator, we give it a detector, and then we authenticate with role-based access control with our cluster. We open our bucket, and this is where we can start using our bucket. And here we are simulating some work. What we'll do is we'll fetch a document from our travel sample dataset, but you can see that we give it a timer of 1 nanosecond. So this will basically help us to quickly simulate failure, right? We are simulating timeouts. Normally, you'd have something like, I don't know, 1 or 2 seconds here, and for some reason, you'll get a timeout after 2 seconds. And we'll sleep so that we don't, like, we can in a nicer way, look at the log output and figure out what's going on. So what is going to happen is that we'll run operations, and very quickly 5 of those operations will time out. Then the failure will be signaled. Then there will be a grace period of our, what did we configure? We said 1 second. And then we will do the failover, okay? So let's run this. So you can see the timeout starting to come up. If we switch to our UI, basically, so that's the first cluster, right? You can see it tried to do those 5 operations, and then after the 5 operations, what happened is that the topology changed to the other cluster, which is Vienna instead of San Francisco. And then if you look at the statistics here, then it starts doing the operation on the other cluster, right? So that's what we wanted. It transparently failed over, turned off the operations from one cluster, start talking to the other. Then of course we still have the timeouts because, well, we don't get responses in 1 nanosecond from this other cluster either. But you can imagine how it will work. Okay, and as another little more realistic example that I can show you before we close out. Is what you can also do in addition to failing over from one cluster to the other completely, you can also fail over specific nodes, right? If one node of the cluster goes down, certain partitions are affected, and the way you can set it up is that you can talk to both clusters at the same time, and the disaster recovery cluster will only serve those partitions that are on the down node. So the way we set this setup up is very similar to here, right? We point to our cluster, and in addition to setting the grace period on our coordinator, we also tell it, hey, wait a minute, we need 2 active entries instead of 1 all the time, right? Otherwise, it's not allowing to do that. And we give it another option saying only perform the failover if 2 or more nodes are failing at the same time. And here's how we set up our traffic monitoring failure detector. We still have our 5 operations in the time interval, but we also scope it to a node basis. So previously, those 5 operations would be counted on the whole cluster. Here, they are counted on a per node basis.
No, actually it's not. It's operations.
Sorry?
You're good where you are, but if you go more right, we cannot see you on the
Okay, okay. I don't know if you need to see me on the live stream, I don't know. At least you get to see the stuff over there. Okay, so again, we are connecting to our cluster, and now we are performing some real work. We are not setting an arbitrary timeout. We set a 2.5 second timeout, and we fetch our documents. So let's run this. So this is single threaded, and this has some impact that you'll see in a little bit on the screen. So if we go to our San Francisco cluster, you can see, okay, we are doing operations on our 2 nodes, right? So 101 and 102 are serving data, and our other cluster is idle, right? Everything is going fine. Now let's stop node 2 on our first cluster. What you'll see is timeouts, right? Expected. But now it takes a little longer since it's waiting 2.5 seconds until it figures out there's a timeout going on. And now what happens is that if we look at it on a per server basis, here the 102 machine, of course, is shut down. So part of the operations are going against the first cluster, and the operations for the failed cluster, for the failed node, are going to the second cluster, right? So at this point, we are transparently distributing operations between both clusters, and no timeouts anymore, right? So that's just one of the many different ways how you can set up the system. It's highly configurable. We are still working on it, of course. It's a work in progress. But it significantly reduces the number of development work you would have to do if you set up something similar, right? I think with that, I just got the signal that we need to wrap up. Thank you very much for attending without a break after the keynote. And if there are any questions, both Mel and I are available the whole day, and we're happy to answer any more questions. Thank you very much.